double slit experiment. So there was a student in the class who was curious about what the observations would be after slitting more. So after the first presentation, which is a double slit, he asked, what will happen if we have a third slit? And what will happen if we have a fourth slit? And subsequently, infinite slit. And then even asked that, what will happen if we added more screens in between the existing screens? So this became more like a chaos or frustration in the class. And this student later on was identified as Richard Feynman. But Feynman later on went on to make it as a postulate that exists today, or what we know today as path integrals. So his trick was just a little thing. In the quantum space, a particle would move from one point to another. So you visualize it at an initial stage, and then you visualize it at a final stage. But through this, there are several paths or several motions that occur, which the eye will not see, it won't be visible to the eye. So Feynman came up with calculations very much more fancy, and he did this with a little trick by just slicing the time that the particles would go throughout the several paths that they would use to get to the final state. And then after doing the time slicing, he just did, okay, let's go back to classical mechanics, or what we know from our high school physics. We know the Earth is like acting on the least level. So the principle of least action comes here. So Feynman used the principle of least action. He borrowed it from classical mechanics into quantum mechanics, and then he realized that, okay, so all these time slices has a very least time. So he related this least time, and then in quantum it's just space. So this time we just take a space, and then from there he did what we have as a calculus calculation. I'll take you there in the subsequent slides. And then he resolved to have this path integral to say that a particle will move from an initial state to a final state, as you all would know. But before it gets there, there are several paths that it will take to get there. So if we all remember, before we all segregated into our various courses, we took 3 days of quantum mechanics. And so our lecturer introduced us to this experiment. We did it here with the lasers, and I'm very sure that you will all recall. This is the double slit experiment, and we have our particle at initial point S going through this double slit. So A1, A2 are the slit, and then hitting the final screen. Now, the superposition of these waves that are going through, and that also occurs in the third, the triple slit experiment, which is also seen here. You have the particle being visualized here, and then the waves go through the slit, and then finally it's seen at the screen. And then even for multiple slits and multiple screens, the observation, so you can see that the particle, you can trace one particle going here, but when it goes through the screen, it could come here and then finally get there. And then it could also join here and then go there, passing through different slits, making us to realize that in the quantum realm, the motion or the movement is not direct or finite. It is infinite. There could be several occurrences that would happen. Right, so this is a pictorial, what I just said now. So we can see that the particle would have a continuous path, but you can see that it could have this motion, it could have this, it could have that, and this is quite self-explanatory. Right. So let's get to the mathematics. Before Peter introduced the Schrodinger equation, and in quantum mechanics, this is like the backing or the governing equation that holds it. So we also refer back to our quantum class in the early days where we introduced this part of the Schrodinger equation to be the propagator. Now when you break this down, you have this coming here. So we'll go into path integral calculation here. I mentioned earlier that the particle will have an initial point and then get to a final stage. But this over here is the time evolution, or what really occurs in the quantum realm. So for initial state to get to final state. Time, that there has to be time evolution occurring, and then we have this also happening. So this is like an expansion of this to tell you the three dots are like repetition of the occurrence here. Now we'll introduce the identity here to say that this has like several, occurrences in between here. So we have the identity as